Today we are going to look into uh, this title, Solving Regression Problem Using Machine Learning Modeling, especially with reference to support vector machine as a case study. Okay, how can we model regression problem using machine learning? It's all procedures are the same procedure as we've itemized before. So you always have that particular flexibility of looking at your data set. So quickly, if your data set is set for modeling, go into the platform. WEKA as a case study, we're going to demonstrate it there. And then do a quick modeling by selecting the appropriate algorithm. So, and then check the result of the modeling, the performance measure. If it is not yet okay, you can always go back. There's opportunity for you to do looping. Go back again to modeling by selecting another, by kind of optimizing your hyperparameter values, which we call hyperparameter tuning. Do the tuning and then check it again until you get something reasonable. Sometimes the algorithm you selected might not be able to get you good result. Then you might have to go back and change your algorithm. This is very important. So you keep changing. Then when you change the algorithm again to a new one, then you do the hyperparameter optimization. And then this continues until you achieve what you wanted. Sometimes you might have to go back to the data preprocessing, where you might have to do feature engineering, where you may have to just carry out some feature selection. Maybe the features are just so many and the number of samples is not meeting up. So it's practically the same procedure like you did for the case of classification problem. The only difference now is this one is predicting numbers, real values, while in classification, it is all about just categorizing into groups. So another thing that we can notice that is different when you talk of regression is you're going to have this kind of, which kind of regression equation is going to work for me and which one will not work for me. So you can see here, unlike in classification, where we are just trying to identify and group items into their respective classes. So here you are going to have the appropriate equation that is going to form the correct system to be used. So is it the correct one that is going to model our data? Always remember you let the data speak. Maybe it's this one that is going to work for you. Maybe it is the straight one or a little bit curved one. So we have different systems that you're going to have. This is the weight. This is the input. And this is kind of variable that is often added depending on the problem we are actually solving. And depending on the kind of algorithm we are using. For example, in the case of support vector machine was originally made for classification, but was later extended to cover the case of regression. So that's why you have some of the machine learning algorithms, they are both capable of doing both classification and regression. Depending on why you have few of them, very few of them that are meant to do only one problem solving, like logistic regression. Even though the name looks logistic, logistic regression is only for classification. You see, why we have linear regression, multiple linear regression for the regression problem. Another thing that we have to take note that differentiates classification from regression is the performance evaluation metric that you are going to use. This is also very important. So the evaluation metrics, they are totally different from the one of classification. So, and how do we select the appropriate one to use? There are several evaluation metrics for regression. However, the best way to select it is to look into the established performance measure in literature of the targeted field. You see, unlike the classification whereby we have standard classification measure that is common to all. However, for regression, it depends on the area of application you are looking into. For example, in software engineering prediction, they have some special performance measure for regression problems there. So you have to follow it based on the literature you have to first of all review. So in oil and gas, you have some of the established performance measure that you have to follow. So you have to check the literature. However, if you are the first one to model in that area, maybe in your area of problem solving, no one has ever worked using machine learning to solve the problem. You are the first one. Then you have that particular flexibility in being the first one to actually design what other researcher will follow in future. So if you are in this category, so there are very important I do recommend for people. This is the correlation coefficient, what people call it R square, with this formula. So you have to use it. It's very common. It tells you the correlation, how the predicted value is correlated with the actual value that is expected. The closer to 1, the result, or 100%, the better. You see, the closer it is, the better. It means as the prediction is increasing, so also the actual value is actually increasing. It means they are apart from each other. So another very important one is the root mean square error. Root mean squared error, which has this formula. It actually gives the actual error. See, what is the, let's say this is the actual value and this is the predicted value for the first case. You find the difference between the two and you squared it. This is the actual value for the second sample. This is the predicted value for the second sample. Find the difference, square it. Squaring it is just to eliminate negative answer, negative value. Because if we have negative, positive, negative, positive, they cancel each other. So we don't want that. That's the essence of squaring it. Mathematicians in the house will tell us more. So it's just to make sure that we are trying to estimate the actual difference between the predicted and the actual value that is expected. So that we squared it to negate the negative effect. So at the end of the day, you are going to have the summation of the square of all these, and we are going to do the square root again, which mathematician will tell us we have not done anything. The squaring will be negated by the square root finally, which gives us what we refer to as root mean square error. You are the first one to work in this area. You check the literature. No one has ever used machine learning regression model to solve problem in your area. Then I recommend for you to use at least these two. They are very important. Why this one shows you the correlation, how correlated the prediction is towards the actual expected value. This one will tell you the exact error, how far away from the actual value were your predicted value coming out. So there are other measures you can use, like I said, depending on the area. Absolute percent relative error, standard deviation also could be used, and things like mean absolute error, mean error, mean absolute percent error, mean percentage error. This is very common. I use this one and I recommend it for starters. So it always tells us the actual error you are having there, the coefficient of determination, and difference between the actual value and the estimated value using plot or figure. This is very important. You see, after you add your plot, after the prediction, try to take out the actual value here. So first of all, you print the expected value, which is not given to you. Okay, these are the expected value. So you can have a line to join them together. So after your prediction, then you see what is your prediction. Your prediction sometimes is even on top of it or very close to it. In that case, another line will join your prediction together with the actual. Then you can be able to have an idea of how close your prediction is to the actual.